Okay, and then the last part of this chapter, radiation, and then after that we have a few questions at the back. Alright, so let's go. Yeah, just pause the video here if you feel tired. You can like continue on later on or tomorrow. Alright, okay, so let's go. What is radiation? Right over here. Now, radiation is a method of heat transfer by which a heat source transmits infrared electromagnetic waves. Okay, so remember at the very start I say that radiation is transfer of energy by waves. Okay, now we have this thing called the infrared wave. Okay, it's a type of electromagnetic wave. Now to make sure like we understand whether something is going through conduction, convection or radiation, there's this term that we always use when we use radiation. Instead of saying heat transfer, we say that radiant heat is being transferred from one point to another. Okay, now here does not require in any medium. Okay, because wave is not particle, it does not require particles. Okay, that's why it does not require any medium. Can take place in a vacuum. Okay, and over here the term that I mentioned earlier, radiant heat. Okay, now in this simple experiment, right, okay, the one on the obviously the dull black surface drops first. Alright, and this is because dull black surfaces are better absorber of radiation or radiant heat. Okay, cancel the word radiation. Okay, better absorber of radiant heat than shiny ones in general. Good absorbers are also good emitters. Now in this case I know that I have to write better absorber and not better emitter. Okay, emit means give out. Okay, I have to write absorber. Why? Because heat is transferring from the candle in this direction, okay, to the two plates. Now in this case, right, the dull black surface, the purpose of this plate here is to absorb, it's not to emit. Okay, so it absorbs the heat, okay, and then the object here actually gets the heat and then it will fall off. Alright, now the object getting the heat here, right, is by conduction. Okay, because the object is in contact with the plate. Alright, the plate getting the heat is by radiation. Okay, because there's no contact between the film and the black plate here. Alright, now emission of radiation, okay, emission of radiation, the hotter an object, okay, the more energy it emits. Okay, or rather it radiates. Okay, dull black surface are good emitters or radiators. Okay, usually we just say emitters, we don't say radiators. Okay, so this is a keyword. Then shiny silver ones. Okay, the larger the surface area and temperature of the object, the greater is the rate of heat transfer from it. Okay, now good emitters are used in situation where heat has to be quickly dissipated. Okay, that means given out, right? Remember? Okay, now so at the back of your fridge, right, you have the cooling fins. Now they are dull black because they are meant to emit heat at a fast rate. Okay, so what happens is you know your fridge is cool, right? Okay, so obviously the air around it is not cool, right? So if you go to like departmental store where you have like unpowered fridge, you open a fridge, it's just a normal temperature air. Okay, so obviously the fridge does something to the air, it takes the heat away from the air. Okay, now if it takes the heat away from the air, it has to give the heat off somewhere else, and this is the region where the hot air is given out. Okay, or rather heat is given out. Let's not write hot air, heat is given out. Okay, so if you go to the back of a working refrigerator and touch this black fins, right, it's going to be super hot. Okay, because heat is being given out there. Okay, it's taking like a lot of heat from the normal temperature air and making it cold. Alright, cold to the point where you can start freezing water and freezing your food. Okay, so that's like how cold it is. That's like how much work the fridge is doing. Okay, and therefore this has to be good emitter. Okay, so if it's not good emitter, right, can you imagine the heat does not escape fast enough, right? The fridge becomes like a heater instead of like an ice box. Okay, now explain why a silver teapot keeps tea inside warmer compared to a black teapot. Because silver is a poor emitter. Now tea is hot, right? Okay, so we have a teapot here. Okay, whatever. Okay, so we have a teapot here, right? Now the tea here is hot. Okay, so remember, heat transfers from hotter region to colder region, so heat is going to transfer in this manner. Okay, in this case you don't want your teapot to be a good emitter. Okay, so you have to be very clear whether this is an absorbing question or emission question. Okay, in this case this is an emission question, so this is the first time we are doing this, so I'll just write the answer here for you. Silver teapot is a poor emitter of radiant heat. As such, heat loss will be lesser than when it is black. Okay, so heat loss will be lesser. It helps to keep the tea warmer inside. Alright, now uses of good absorbers are used in situation where heat must be quickly absorbed, right? Okay, so most of the time you'll see your solar panel, they're actually in dull black paint. Okay, now I just want to Google this for your solar panels, right? Okay, now over here, most of the time when you see solar panel, right, because you see it from afar, right, it looks like this. Over here in the center, it looks like super bright. It seems like shiny or what. Okay, it's not. Okay, the only reason is because it's reflecting the light from the sun. Okay, like this is a proper solar panel. Okay, so you realize it's actually dull and black. Okay, it allows you to absorb radiant heat at a fast rate. Okay, so let's continue. Explain why solar panels are painted black. I think I just explained it. Okay, because you want them to be good absorbers of radiant heat. Okay, and yeah, that's why they are painted black, because black is a good absorber of radiant heat. Okay, as such, a summary of like what we have talked about. Let me take a look. Do we have here? No. Okay, as such, right, as a summary of what we talked about, I want you all to come up with this table. Okay, then we have the good emitters and absorber, and then we have the bad emitter and absorber. Okay, so we have like white, shiny, dull, and black. Okay, so usually, right, good emitters and absorbers, right, are dull and black. Okay, so if you put shiny and black, right, it's not as good. Okay, so you want it to be dull and you want it to be black. Okay, by the way, texture matters more than color. Okay, if it ever appears, texture matters more than color. Okay, if I have time, I'll go through the reason why. Okay, but anyway, texture matters more than color. Okay, so if we were to compare, right, a dull white is better than a shiny black. Okay, so this thing, dull white will actually win. Okay, shiny black will actually lose. Alright, and a bad emitter and absorber will be shiny and white. Alright, and we're almost done. Okay, now to sum everything up, right, let's look at vacuum flask. Okay, a vacuum flask is a good example to like close out this chapter. Okay, a vacuum flask keep hot liquid hot and cold liquid cold in 4 possible ways: conduction, convection, radiation, evaporation. Right, so please write that down. Okay, and then we'll look at how vacuum flask actually works. Thermal flask. Okay, we call this the thermal flask also, right? Okay, now vacuum. Okay, so you realize there's a vacuum here. right? The one that I'm shading in blue right now. Okay, so this is the vacuum, and it prevents conduction. Okay, actually it doesn't prevent, okay, because there's no like perfect vacuum in like this kind of flask. Okay, it's more like minimizes. Okay, so if you want, you can change all the prevent to minimizes. All right. Okay, but theoretically prevent is correct. Okay, so anyway, vacuum between double glass wall prevent conduction and convection from happening. You realize both conduction and convection requires particle. Okay, and therefore, right, the only way heat can go in or heat can go out is by radiation. Okay, now trap air above liquid plastic stopper. Okay, so over here. Okay, it prevents conduction from happening. Okay, so yeah, see, actually air does allow conduction to happen, right? So it actually minimizes it, not really like prevent it from happening. Okay, now the plastic stopper prevent the exchange of air between flask and environment, right? So basically, like trapping either the cold air or the hot air inside. Okay, so by right, if it's hot air, you will want to rise up, but because of this plastic cap, right, it cannot rise up. It's only going to circulate within this region. Okay, if there's no plastic stopper, right, it will actually rise up. Okay, and the cold air from the surrounding will actually sink in. Okay, that's how like convection cools your drink. Okay, when you don't cover it. Okay, now silver walls of glass prevent. Okay, so same thing, it doesn't prevent. Okay, it minimizes. Okay, so silver is shiny. Okay, so shiny, this one really cannot write prevent. Okay, this one must write minimizes, yeah, because it really doesn't prevent. Okay, minimizes the emission and absorption of radiant heat. All right, and we are done with this chapter. Okay, now I just want you all to do a quick summary over here. Okay, so like do it on your own. Okay, pause the video. I'm going to give you the answer now. For conduction, right, it happens as long as there are particles, because they just need to vibrate and collide with one another. For convection, it happens between fluids because the particles need to move around. For radiation, it happens for all because you don't require any particles. All right. And I think the questions here you can try on your own. Then I will want to collect this page 17 and 18 from you next week. All right. But otherwise, I'll just end the video here. Yeah, please like cut into your own segments and like pace yourself. All right. If not, let me go to the cover page here. Here. Wow, it's taking quite long, right? Amazing how we did like 16 pages. Please do not write this for Thursday test. Otherwise, okay, have a good day. Bye.